Assalamualaikum warahmatullahi wabarakatuh. We are from Group A. Today we are going to present about the flow over wheel for our own applications. Our team is consists of 4 persons, which is me, Muhammad Hafiz bin Sam Sabadra with matrix number 207030, Ahmad Dini bin Ismail 208078, Aiman Amir Farish bin Kamisan 208224, and Ahmad Nazir bin Adnan 208014. So without any further ado, let's go.
Assalamualaikum warahmatullahi wabarakatuh, and good evening. My name is Ahmad Dini bin Ismail and my matric number is 208078. So today I'm going to present about flow over waste experiment and the theory of the flow over waste. Okay, so what is Weirs? Weirs is a barrier that spans the width of a river or stream, which then altering the flow characteristic and usually resulting in a change of the water level height. There are many types of weirs. For example, a rectangular weirs, a trapezoidal weirs, and also lastly a triangular weirs. So for the report, we are going to choose a rectangular weir. Rectangular weir is able to measure a higher flows, with the flow rate then of a weir, which is related to the height of the water above its base. Thus, the weir can be used as a flow measurement tool, and the relationship of a flow over waste can be obtained by applying the energy equation from a point well upstream of the weir to a point just above their weir tracks. And next, there are two diagrams. The first, the left one figure show a formula for the calculating the flow rate of the rectangular weir. So the approach of the flow rate of rectangular weir can be represented, which Q is representing a flow rate, CD represents the coefficient of a discharge, H represents the water height, and lastly B represents the width of notch. That's all for me. Thank you.
Okay, so here we comes with the pictures of application flow over rectangular weir. So the figure shows the rectangular weir that we have found located at Bukit Expo UPM. So these are all the 4 pictures that we have managed to collect, and it is come from a front side of the weir, top side, right side, and also the left side. So the main purpose for this experiment, the practical application, is about to determine the characteristic of flow over a rectangular weir. So we have managed to observe the flow clearly that have run through over the weir.
Okay, now we will continue with the discussion part. Okay, the aim of this fieldwork is to investigate the flow characteristic across a sharp-twisted rectangular weir. The fieldwork's objectives were met since the flow characteristic could be analyzed as we went and observe the place that has the sharp-twisted rectangular weir. The location of the fieldwork was at UPM's Faculty of Engineering. A thin vertical plate is placed in an open channel to estimate the discharge by sharp-twisted rectangular weir to ensure the utmost minimal contact with the liquid. The downstream side of the sharp-twisted weir's edge is bevel, about 0.2 times the thickness of the weir plate makes up the thickness of the weir at the case. The bevel surfaces on the downstream side should form an angle between 45 and 60 degrees. The heat over the weir case H is measured at a distance sufficiently upstream that is at least 3 to 4 times the heat to be utilized to calculate the rate of flow. It is impossible to study the thin plate weir flow pattern just theoretically due to its complexity. This is brought on by the distribution of non-hydrostatic pressure, turbulence, frictional effect, and the flow characteristic of the approach. At low heights, surface tension and viscosity impact also become significant. Thus, after making a few simplifying assumptions and appropriately altering by empirically observed coefficient, the analytical relationship between Q and H is achieved. That's all for me. Thank you.
So for the conclusion, the distribution of velocity on the approach flow has the noticeable impact on the discharge over the weir. A smooth flow and over the weir is critical for the determining correct flow rate. The discharge coefficient increase as the flow rate increase. It add higher to the notch and round down it when the flow rate is too low. This alters the coefficient of discharge since the water now has a content with velocity and friction on the null surface in addition to gravity. The experiment's theory assumes that there is a minimum height of water above the notch, and that any height below this begins to vary from theory at an increasing rate. The heat of weir and the discharge of water over the weir have the direct proportional connection. Lower flow rate result in lower height above the nose. So that's all from us. Thank you.